Overall, the kind of firewall configuration we've described so far is a stateless firewall configuration. It manages to get at a little bit of the state in the sense that TCP connections can be recognized with whether they have the ACK field or not. But more generally, you can have firewalls that allow treatment of connections and routing of packets based on what connections they belong to. This needs more information. It needs to keep state about what kind of connections it saw formed, and this kind of tracking is very similar to what we saw for a NAT router. And in fact, firewall and NAT functionality are often bundled together so that they can both take advantage of that tracking. For even more fine-grained control over network access, we're going to have to move up from the network and transport layers. At the network and transport layer, I can easily completely turn off web server access or completely turn it on, but it doesn't let me select some sites to be accessible and some other sites to be accessible, or make any distinction about paths within those sites. At least not easily, because we could list all the IPs of all the web servers we want to allow, but that would be tedious and limiting and probably not work well with extra resources that the web page needs. An alternative is to look in more depth at the packets and understand the protocols that they're implementing and make more protocol-specific adjustments to the packets that are let through. This idea is sometimes called deep packet inspection. It's an idea that was more common in the early 2000s. It doesn't work as well as it used to because packets tend to be encrypted, and so deep packet inspection is not possible at the router level. If you do want to do something more specific to the protocol, then probably the right way to go is an application gateway. An application gateway doesn't have to work at the network or transport layer. It works with the cooperation of applications that are using a particular protocol. So, for example, if you're using the HTTP protocol from a web browser, then web browsers have the ability to route those requests through some other machine that is acting as a gateway for that particular application to do things with the HTTP requests. And these ends here agree on how they're going to encrypt things so that the gateway has the ability to look at the content of the packet as opposed to just where it's going to and where it came from. This gateway then could limit access at a rather fine-grained level, or it could authenticate access to certain sites, or rewrite dangerous web pages to fix up the safety of some sorts of sites. And application gateways are particularly common with HTTP. Most applications that use HTTP will pay attention to the HTTP proxy environment variable to decide what other machine to route all HTTP queries through. The protocol that gets layered on top of HTTP here for the client and the gateway to communicate doesn't have to be the same as HTTP. Some common protocols do use HTTP again as the mechanism that requests are sent to the gateway. There's another protocol called SOX5, which is less HTTP specific, and so it can do less kinds of filtering, but can be used in more general situations. We'll take a look at both of these in a moment. Some environments force proxies to be used, but they tend to be slower and less convenient than direct access to the internet. So it tends to be a last resort for creating a firewall between some end-user machines and the rest of the internet.